I'm going to continue. No, something mentioned actually yesterday after the keynote, when I talked about the math question when we saw off the corner of the board, and it was said that this is a testing question, something that is used to teach testing. We touched upon this yesterday at the lightning talks. Hands up, who was there at lightning talks? A few of you. Because lightning talk takes about 7 minutes, it wasn't really, a deep dive. We just scratched the surface. But these questions are designed to have unlimited number of answers, as we figured out yesterday. But what's the point? How does that help us become better testers? And the example that I gave in lightning talk, and I'm going to start with that today, because that's the one I've used the most to clarify the situation. So we're going to do that, and then we'll talk about what's behind it and what's the point. So think in your own head for a while. Try to figure out the answer to the question I'm asking, and then I'll point at people, and we'll get some random answers, and then we'll go through it. Imagine you're working with your Windows laptop. You happen to glance at the bottom right corner where usually the taskbar is, and there's a clock there, and you see the numbers 11:23. At some point later, you glance down again, and you see it's 11:24. And the question is, how many seconds have passed between those two moments? Those of you who have heard this question before, I ask you not to answer it right away, but everybody else, give me what's your guess? What would be the number of seconds between looking at it, 11:23, looking at it again, it's 11:24. How many seconds? Just shout, I can hear you. Less or equal to 60? Nice. Anyone else have other opinions? I like that you already give a range, because you know that it can be a variable. Cool. We'll come to that. Sorry, what did you say? On average 30. Cool, we're doing statistics. Refresh rate, how does that matter? So, okay, let's say it's a normal, average liquid crystal display screen. We use average 60 hertz refresh rate with 1/16 of a second. So how does that influence the answer? So it's the lowest limit. So you said the upper limit is 60, and you say the lower limit is 1/16 of a second. I mean, it makes sense. You can't see the change unless it has physically changed, right? Okay, that's a nice range. Do you have any other opinions about the range? Any other limiting factors? He doubled your... 120 is good. Obviously, it's... Yes? So he doesn't like your 1/16. He likes 1 second. As long as time exists. Okay, there might be a situation where that's true. Considering within 1 day, let's say it's 1 day, within 24-hour limit. What is the upper limit then? 59 minutes, fine, no, fine. I guess there is can you give me an example of a situation where it would be 23 hours and 59 minutes? Okay, maybe everybody didn't hear, but what she said was that when you push your whatever work as a deadline, last minute, you work through the day to get everything done, it might be 23 hours. Well, and you said it's a real situation. Then I don't really believe you. I said you look at it, it's 11:23. You look at it again, it's 11:24. How come then it be within the 1 day, 24-hour limit? It can be that. It can maximum be then 12 hours and a little bit more-ish. So it's not the next day, so it's still the same physical day. So it can't be 24, but it can be somewhere there. We can argue that there are cases like that. Did you figure out why the 120 makes sense? Exactly. Exactly. It can be the next day, the next year, or it can be any other complicated setup. You might have been looking at screenshot in full screen mode. So what you see in the taskbar is not an actual clock, but it is, a screenshot for something because you're checking something that was happening and you're working like that. Or Windows time server has been hacked and the time it displays is God knows what. Or as some people say, it could be because you were traveling and coming out from your plane and the time zone changed because you got a new signal from the Wi-Fi and it switched to the new one. I mean, it could happen like that. It also could happen that, while you were away, somebody changed the time on your computer, or there was a virus, or Windows froze, or any number of situations could have gone wrong to influence the time. But the simplest answer is obviously mathematically maximum little bit under 120 seconds if we consider it the same minute space, because it is 60 seconds of the first minute and 60 seconds of the 24 and the time there. All these options are great, but how does that help us become better testers? When I use this question with young testers, it's not to make them be annoyed or have a gotcha. You didn't think about Windows could be hacked or somebody could be messing with you. You didn't find the right answer. That's not the point. The point is to get them to think about what else could be manipulating my test object. If I'm testing any product, I want to limit my inputs so that I control the experiment that I'm doing so I can have some reliability in the results that I'm seeing. So to have predictability, if I have to repeat it, would it happen again? If the inputs are very random, I can't trust what I'm doing. I can't build my evaluation of the product's behavior, which is why we use specified inputs. We design our test inputs, we design our test data so we could limit the factors. And this question is designed to help testers think about that. What are the other inputs to the system? What are the things that are making my system work in a way that I wouldn't realize, but is actually affecting it? And in this case, I also, I can draw the line of, okay, well, it's your computer, it's simple, right? But it isn't, because it relies on data from internet to get the right time. The Windows operating system is known to have secrets, how it behaves and why it does things. And it has bugs. We know that it has bugs. Even the simple Windows calculator has a bug. If you do 4 minus 4, you expect to get 0. You don't. Okay, maybe it's not that simple. You first have to make a square root of 2 and then take it to the root of square of 2, and then I guess square of 2 again. It'll show you 4 on the Windows calculator. It'll just show normal 4. If you do that, minus 4 from that, it'll actually show you the 1.6 times 10 minus 68 or something, that it has the roundup error in it. I mean, that has been there for years. Everybody knows that. Well, nobody really cares. They said they're not going to fix it because it's too complicated. But the point is that there are things that can influence how the data or how your product is operating. Even if it's as a simple aspect of you're using a database, you're putting a string in it, but the database optimizes it. It converts it to a different format that might have some kind of limits, or the other way around, not as much limits, but it does some kind of optimization. So there's underlying functions that are working that you might not be aware of. And using questions like these helps a young tester to figure out, hey, what else could be influencing the product I'm working with? But this question specifically is designed around that and around times, because if anybody has tested any calendar application or any kind of application that relies on specific and correct timing, they know that it is something that becomes very muddy very, very, very quickly. Not even because of time zones, but because of how different systems calculate it. Delays. Oh, that was a good example. We were doing wireless streaming 15 years ago at Bang & Olufsen at the time, because they were known for having great audio quality, and we wanted to have audio streaming from their devices wirelessly. We were really good at the wired one, but the wireless one was back then not good. So we tried to use Wi-Fi-based streaming. It worked well, close enough. There was, you have to buffer a bit and so on. But we had a bug at some point. Every 3 minutes, there was a cut in audio for about 3 seconds. Like, this makes no sense. But it only happened with certain routers. And we knew that, and we had tested different kinds of routers, the ones suggested from Apple and all the other important suppliers. And there was one expensive one. I think it costed like 1,200 euros at the time, which for a router is, home router for your home internet is very expensive. But that router had a specific function. Every 3 minutes, it was scanning the range of Wi-Fi bandwidth usage for possibility to extending the range that it uses in order to give more bandwidth to the client. So it can detect if the bandwidth is in use or not. So it can extend the range of bandwidth, or the hertzes that they're using, so you can give it more freedom. But while doing that, it limited the traffic that it was able to let through. So they dropped our bit rate horribly. We're like, we can't do anything with it. We can't go to the supplier and say, hey, turn off that feature. Actually, we can. We did. They ignored us. So we just told our customers not to use the specific wireless configuration N or F or whatever that was that had that option of extending the range. But I mean, obviously, clients weren't happy about that. So there can be a underlying component that makes it difficult to test or to have trust in your test data, because you don't know what's there. There are other types of questions that are used to focus on other things. One of them is the cutting of the board thing, which is more related to requirement handling. So that was the question about, okay, what is a corner? What is a rectangular board? Why are we talking about this? And the reason we're talking about this is trying to clarify what is the requirement, what's the meant behind that requirement. The example I gave in the lighting talk yesterday was, this product has to work with voltages between 110 and 250 volts, which is the normal application rules for most devices in Europe, at least, because we work with 220 voltages compared to the US that works 110, I think. And there's 50 hertz, and we have 60 hertz, and all that jazz. But that requirement by itself seems rather simple. How do we test it? The usual answer that a young tester would give is, well, we have a range to test. We know boundary testing. So it's -1, +1 in the lower end, -1, +1 in the upper end, and somewhere in the middle to make sure that we have covered close enough. Because we need to minimize. We can't exhaustively test everything. And that is one of the things that you could do. But then you have to realize that electricity doesn't work that way. At least AC current doesn't work that way, because it's alternating all the time. And it's never stable. If you read your energy company statements about the quality of the electricity, you see that they have a statement that 99.5 percentile, it stays between this and this range, but you expect spikes up to this in these frequencies, etc. So it's actually doing that quite often. It's just hidden away by the magic of hardware. But for testing purposes, you might still have to think about that. So, okay, we have to test our product also when it spikes over. For a couple of milliseconds, it spikes over to 50. What happens? Obviously, product was designed for it, but you have to think about that. But the other question that comes from that, usually from that requirement analysis, is why should we? Because the product isn't meant to be working outside of those ranges. Why should we test something that is known to be, give us a negative result? Any ideas? It fails gracefully, exactly. We have to make sure that, make sure is a very tricky word to say. We have to test and see what happens if we go above or very much below of these ranges that is accepted, to see what else happens. If we put in a really wrong string, does it overwrite something else? Because we'll go over the limit that it's supposed to have, and we're not truncating things properly or sanitizing our inputs. Or in the case of hardware, will it explode, or will it just do beep, 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 and turn off, as it should do, because normal power supplies nowadays have this detection built in, and they can turn themselves off to save themselves. But that's the idea of that question, is to understand and analyze that requirement of what is a board, what is meant. Is there a purpose why we're cutting off that corner from that board? Do we need to have a specific shape? What does the customer need? Do they need both parts, or they just want one part of it? And you can argue around that. And then I usually introduce the heuristic of Mary had a little lamb. Anybody know that heuristic for requirement analysis? No hands? Really? Oh, there's a hand. So what it is? Yes, you can use the Mary had a little lamb to question every word on it by, as I explain it, by emphasizing it. Mary had a little lamb. So the important part is that Mary had it, not somebody else. It was just Mary, specifically Mary. Mary had a little lamb. She does not have it anymore. What happened? What is the significance of that situation? Is she lost? Who knows? Mary had a little lamb, a random lamb, doesn't matter which one, but she had a lamb. Or Mary had a little lamb. In that case, it was specifically a lamb, not a goat, not a fish, whatever. And the same way you can look at every requirement or every specification sentence you have, and just, if I emphasize different parts of it, what kind of questions should I ask about this? Do I really understand what is meant by this? What else is there involved? So it helps to focus on that part of the how shall we put it, that part of testing of understanding the customer or the product that we're dealing with. I'm thinking which one of the questions is one of the most annoying one that's been used. Oh, I'm going to use a bottle. There's a testing challenge. I mean, that's less training, but there's a testing challenge that goes like this. Look at this bottle. Focus. See? If this is a bottle, and this is a bottle, is this a bottle? It's a yes or no question. Yes, it is a bottle. Good. If this is a bottle, and this is a bottle, is this a bottle? No. Focus. Check this out. If this is a bottle, and this is a bottle, is this a bottle? Yes, correct. If this is a bottle, and this is a bottle, is this a bottle? Good. But check this out now very closely. See what I'm doing. If this is a bottle, and this is a bottle, is this a bottle? Yes, of course it is. This challenge got a lot of people very annoyed at the testing conference when it was used to make people think about testing. This turned out to be less about testing and more about paying attention to different things, because you can do that with whatever. We did that with, is this a pen, and this is a pen, is this a pen, or knife, what bottles, whatever. And it turned out to be, because you start thinking, okay, what is influencing the pattern? What am I using? Is it the way I hold the bottle? Is it the way the bottle moves? Or is it related to something else that's connected? Maybe the sequence. Maybe there's yes, yes, no, no, yes, yes, no, no. Maybe there's a pattern there. So it's more about making people realize that there is there might be a pattern that you're looking for that might not be obvious, that is visible in your test data, or that is visible in your test results, or that is a systematic problem in your inputs that skews your outputs. For that, Michael Bolton has a wonderful testing exercise. It's a program where you can input IP4 addresses. And it said, just put in normal IP4 address, it'll tell you if you found a bug in that program. Because the program, all it does is to say that it checks if this is the real IP version 4 address or not. And there's a number of combinations there is quite huge. But in essence, it's a number of from 1 to 255 or 56, depending on which place it is, and there's 4 of those. So he did that exercise in a class where I was in, and I thought myself, I'm an experienced tester. I know how this thing goes. And I tried. I had done 3 tries when other people in the room were, yay, I found a bug. Or basically, they found the combination where the program said, hey, you found the right place where I have a bug. Time went on. I was about 12 tries in. Most of the other people had already found that bug. I still hadn't. What I had been doing is using systematic approach. Numbers that are usual, local host numbers or something else. And I was like, why can't I find a bug and they can, who don't really know about testing that much? They haven't been in different classes. I'd seen them before. They're just guessing. So what do you do when you get angry? You start smashing the keyboard, hoping that will give you a really random number. When I got to the try 23, having been randomly smashing the keyboard and having no luck, I went back to figuring out what the heck is going on here. What am I missing? Which is a normal heuristic of focusing, going back what you're doing, what you have tried. And I started looking at the inputs because it gives you a log what you have tried. And you start looking at it, it's like, I haven't tried this combination. Tried 1, tried 2, tried 3. And on the 27th, I got the right answer. Statistically, every fourth IP address should have given the error. So I was off by a lot by getting it to the 26th. Turns out the program was designed in a way that the normal, the typical answers don't fit. And the other problem was the randomness that I thought I was using. It wasn't really random because if you think about it, the IP address range, because it's up to 250 something, if you put in numbers randomly, you get a wrong answers a lot because you start with 776 or something like that, which is obviously wrong right away. So how many times you get into the right ranges, and what happens there is you usually get all of those numbers. So it was designed to fool your thinking that you're doing random stuff when you were actually doing similar stuff, just slightly randomized. Again, all that it is about, do you know what inputs you're giving to the system? What is the patterns that you're matching with the data that you're using? And it's a lesson that is hard to remember while you're actually doing testing, but it helps. Occasionally, you think about it. Do you want to know the bottle one, or I shall keep you annoyed for the rest of the conference? I mean, it took me, I think, a couple of hours sitting at the conference with the person. So I'll try it one more time. Look at this. Focus here. If this is a bottle and this is a bottle, is this a bottle? Yes. If this is a bottle and this is a bottle, is this a bottle? No. What was different between those two examples? Yes. The key for this game is when I verbally draw your attention to this, then it's a yes. Otherwise, it's a no. Nothing else matters. It's really annoying to figure that one out. But it's, again, it's a game meant for testing challenges. There are a number of people who enjoy that, me included. But it doesn't really help you learn much, but it's a possibility to make it learn. The same way the game of set is used by testers because it's great. It's pattern matching skills. Who knows the game of set? Maybe a few hands. It's a pattern matching game of figuring stuff out. But it doesn't really teach about testing. It's great for a game to play, but it's very hard to connect that, what are you actually learning with it from testing point of view. So when you're using these kind of challenges, you gotta be really careful if you're actually teaching testing, or you're just teasing people with different skills or different attributes of what you're doing or what you should be doing. I'm trying to remember what was I have a vague memory if there was a really good question used in testing. I mean, the other major thing that I always impress on my tests is that what you need to understand is what is the value of this product. Because we can find infinite number of bugs, you all know that. But which are the ones that really matter? That's the typical question of quality. What is quality? Can I get a definition of quality, Sami? Balance between like
his value to a person.
it's a value to no. I like that definition that quality is value to somebody who matters, because it influences or it highlights the major aspect. It's a part of a product that gives something to somebody who matters. It might be our clients, it might be our internal operators who use the client or use the product, or it could be our CEO who wants to see money coming in because he's selling that product. And a box can have different value, or it could be, if all you're selling is an API that is used by developers, then, what are the bugs there? What's the interface, what we're testing? It could be a documentation is a good interface for developers, although they don't rarely read it or update it. But again, for that product, you have to understand what is the value that is being threatened by this bug, because bug is something that threatens a value for somebody who matters, because it threatens the quality of your product. So understanding that value is a big part of trying to get to tell the story of testing. Because yesterday somebody talked about, in the lighting talks, they talked about the quality metrics. So metrics isn't just raw data. I mean, it can be, but the idea is that metrics have to tell a story of what is happening. If you get a small dip in your graph, is that a problem? It could be, if we expect it to be linear, but it might be fine because we know it's related to something that can change a little bit constantly, so it might not be a problem. But if we see a trend of bigger dips, that obviously is an indication that something might be wrong here. And then it depends on how big of that issue is. Again, we don't really know until we know what it influences for our customers. So we have to train ourselves to understand what does that mean. The number of pods in our AWS cluster or Kubernetes cluster has jumped from 20 to 27 in 2 minutes. What do we do? Is that a problem? Or we just had a surge of traffic? Could be, but we have to investigate that. Maybe if our CPU scaled up at the same time and we see that our error logs have, or error statistics have jumped up as well, crap. Something is most probably wrong and we need to check this out, because as yesterday on this stage, they was explaining that if your cluster is set up in a wrong way, it will see that, oh, I'm overused, I'm running out of resources, I better restart. But if the problem is coming externally, then restarting makes it worse because you're creating a bottleneck that's going to be you have to deal with later on, and it gets worse and worse. So you have to understand that. I think I've strayed off the path of what is the point of testing questions a little bit into the path of how do we know what we are doing as testers. But the testing questions and different challenges are meant to have a fun learning experience, a safe space for the people to go out there, just try whatever to see what happens, to understand how does that influence their testing. But you as a host or the question asker or the mentor, your job is to connect that to the daily activities, what they're testing, what they're doing, help them make that connection and make those examples and make that work. Then it's useful testing question as a training method. Thank you very much.